Aloha! Today we're talking more about quadratics. We're going to talk specifically about intercepts, minimums, and maximums. So hopefully you remember y-intercept, and hopefully you remember that y-intercept is always 0, comma, a number. Well, that's always going to be your coordinates for y-intercept. 0 is the x-coordinate, and then the number will be the y-intercept. To find the y-intercept in an equation, first you need to put it into standard form. And the y-intercept is going to be 0, because it has to be, and that number is going to be c. So it's actually pretty easy. So for example, we got this lovely equation, and I forgot to write this should be equal to y or f of x or something. So 5x squared plus 2x minus 3, what's our c value? Well, c is negative 3. So that means our y-intercept is 0, comma, negative 3. That's it. On a graph, it's also pretty easy. You just have to ask yourself, where does it cross the y-axis? So looking at example 1, the y-axis is here. So if we look, it crosses the y-axis right here. And it's really hard to read, but it says 2, 4, 6, 8, so that must be at 3. So our y, or negative 3, pardon me. So our y-intercept is 0, comma, negative 3. For this one, again, look at your y-axis. It crosses about here. And we can see that's at 4. So our y-intercept is 0, comma, 4. Not so bad, right? Let's talk about zeros. There are different ways to talk about zeros. Zeros, that's the same thing as a root. So if I ask for a 0, if I ask for a root, that's the same thing. And that's the same thing as the x-intercept. Those all three mean the exact same thing. And it's always going to be a number, comma, 0. Always, always, always. Again, if it's an equation, you need to put it into standard form. And then solve using the quadratic formula. And your zeros will be that x that you find, comma, 0. Let's do an example. So good news, this is already in standard form. Sorry, I forgot to add the equal 0. So let's label our a, b, and c. So a is the coefficient for x squared, which is 2. B is the coefficient of x, which is also 2. And c is negative 12. All right, let's use that quadratic formula. So x equals, don't forget to write out your skeleton first. Then fill in your skeleton. So we need a b, B, A, C, and then all over to A. Okay. Then I'm going to use magic. All right, negative 2. Plus or minus. I'm going to tell you this square root. Under the square root, when I plug that whole thing in my calculator, I just get 100. And 2 times 2 is 4. Okay, let's split this into two different problems. Well, if I put square root of 100 into my calculator, I find out that's 10. So I get x equals negative 2 plus 10 over 4. And that's an awful arrow. Wow. I also get x equals negative 2 minus 10 all over 4. So negative 2 plus 10, that's 8. Divided by 4, that's 2. Negative 2 minus 10, that's negative 12. Divided by 4, that's negative 3. So last step, put it in this format. So that means that my roots, my zeros, my x-intercepts, whatever you want to call them, are at 2, comma 0 and at negative 3, comma 0. Cool. So that one's tougher, isn't it? Good news. On a graph, to find your root, your 0, your x-intercept, just ask yourself, where does it cross or touch the x-axis? And remember how we found out that, when we use quadratic formula, we solve, you could have two solutions, one solution, or no solutions, right? Here's why, if you've been wondering. So let's look at this first graph. I see my x-axis, it crosses here and here. So that looks like to me -3, 0. And that goes right through the origin, which is 0, 0. So that's what we mean when we say we have two solutions. That means that it crosses the x-axis in two places. Well, if we find out there's only one solution, like this one, it means it touches the x-axis but doesn't quite cross it. And so that point is, let's see, -2, 0, if my eyes do not deceive me. And then look at this one. Look, here's our x-axis. Does this graph touch or cross the x-axis? No, not at all. So this is when you have no real solutions. Is when it doesn't touch it at all. Let's go to the back. So last bit, not too bad, finding out if our quadratic has a minimum or a maximum. So if you have an equation, all you have to do is look at A. And remember, that's an A, not a 2. If A is bigger than 0, then you have a minimum. I know, that's the opposite of what you expect. If A is less than 0, you have a maximum. So here are some examples. So we have f of x equals 5x squared minus 3x. So your A is 5. That means we have a minimum. This would have a minimum. The second example, y equals -8x squared plus 2. Remember, A is the number in front of x squared. It's your coefficient of x squared. So here, A equals -8. That means we've got a maximum. That's it. For a graph, it's even easier. Just ask yourself, does it open up or does it open down? If it opens up, you have a minimum. If it opens down, you have a maximum. So here are two examples. So if we look, this is opening down, because here's our opening down here, and this is the highest point. And our next set of notes, we'll talk about what that's called. It's called a vertex. There, your little head already. And so this has a maximum. This graph opens up. This is our vertex. This is our lowest point. And since it opens up, that's a minimum. Okay, I hope these notes weren't too awful. You've got some practice. Let me know if you have questions.